The importance of the Triangular Neighborhood Networks is that they provide a single constructive language that can provide an explanation from the Big Bang all the way down to quarks. The Triangular Neighborhood Networks are recursive. What this means is that the same syntax works at all levels of structure and behavior. In the video on the Big Bang, I showed how different levels of structure might be applicable to various features in the universe. The recursive nature of the Triangular Neighborhood Networks argues that the number of toroidal holes at all levels must be conserved. This in itself leads to many of the conservation properties. The ability of toroidal holes to move up and down levels of recursive Triangular Neighborhood Network structure makes it possible for the universe to expand and to evolve new properties. The Knupfli plastic elements can be used as a rapid prototyping tool to explore many topological and behavioral ideas. These elements are particularly good at finding symmetries and topological patterns. This is an example of a Knupfli plastic element. It's 1 by 2. It's unit length in this direction and half the length across. These elements can be snapped together to form primitive structures. This is the smallest Triangular Neighborhood Network. It can be grown to be larger structures like this, the icosahedron, and other structures related to it. We can also build very complex models, such as this one shown in orange, which has 3 or 4 components to it. Models of pipes can be constructed like this, and then toroidal holes can be embedded in these pipes. Models of toruses can be constructed. This is an example of a torus connected to a ground state by a pipe. Pipes can be interacted with each other in symmetric and unsymmetric fashions. This particular model was used to show the bending of pipes, which may be related to the bending of light as the light passes a sun. Models of lattices can be constructed. This happens to be capable of being a dual tetrahedral lattice of infinite extent. This model is a junction of 3 pipes that form an infinite dual cubic lattice, which might very well be the electromagnetic field. This simple tetrahedral structure can be considered to be the first level of structure, where each Knupfli edge is one edge in the topological structure. This model is the second level of structure, where each edge has been replaced by a pipe, here shown, and each node has been replaced by a collection of light blue edges here. So together these are equivalent structures in terms of their macro topology, but this structure has many more edges. Each edge in this structure here can, at the next level of structure, be a pipe, for example, something like this. And so we can build a recursion from first level to second level to third level to fourth level to fifth, as much as we wish. Supposing we have our sun, which is a star, and our planet, which is revolving around that star. Supposing sometime in the distant past there was another star or galaxy here, and it was created at a certain time in the universe and started to emit light. It would emit light in all directions, of course. But in particular, let's consider it emitting light towards our star, and also towards a star or galaxy in further away. So in the time that the light would go from here to here would be equivalent to the time for the light to go from here to here. But it's also true the sun, if this sun came into existence at the same time, then it would begin to emit light, and it would travel by some set of means towards this star galaxy here. So this is light from a distant star or galaxy. Consider that as this star or galaxy is sending light in all directions, and particularly in this direction here, that it would join through a pipe to the light pipe that was going from this star here to our star. So this connection here would act to guide the formation of this pipe from this more distant galaxy as it went along, following the path that this star was following. Now, it may be that there's all sorts of hopping and skipping and jumping as we go from galaxy to galaxy as this light pipe is constructed, but let's not complexify the situation too much. So sometime later in time in the universe, the expansion of the universe, the light from this star or galaxy would be here in terms of getting to our star, and the light from this more distant galaxy would only be here. But of course, because of the pipe joining the two light pipes together, this thing is being guided along the same path that this took. And then at a somewhat later time, still, the light from this galaxy or star would have reached our star, and on Earth we'd be able to see this star or galaxy. But the light coming from this more distant galaxy or star would not have yet reached us, but it's being guided along the same path that this light pipe followed. And then finally the light would get from the more distant galaxy to us. In an attempt to try to make sense of the possible utilizations of the two forms of the dual tetrahedral lattices, I've made up this image. Supposing we have a construct of an outer field made of the banded dual tetrahedral lattice and an inner field made perhaps of the vertical dual tetrahedral fields. It should be possible to interface these two field structures on a one-for-one topological basis, and yet the constructions are entirely different. Suppose in the outer field we embed objects which we might call electrons, and in the inner field objects that we might call quarks. This is at least the plausible topological process that we're involved in here, because the dual tetrahedral lattices are infinite in extent, so they can have as much complexity as they need. The objects themselves can be moving around in the fields of their construction, and then in both cases, in the case of the outer field and in the case of the inner field. This is a plausible, possibly plausible construction using the dual tetrahedral lattices, where we use the style of the lattice, the banded style for the outer field, and the vertical dual tetrahedral lattice for the inner field, or vice versa. It makes no difference in that respect. Some time ago, when I first started to think about how to embed the toroidal objects into the ground state and into a sixth field, I built this object in red. It is rather twisted. You can see here how it's twisted, and it has a hole. This looks like a 6-hole here, and it's fully embedded. The path between the sixth field on this side and the sixth field on this side is shallow, shows deep embedment of this toroidal object into the 6 field. So I built out the structure to the point in red, to the point where it was uniform, and there were no more, so for example, no more deviant nodes. So for example, there are 2 5-edge nodes over here, there's a 5-edge node over here, and there's 7-edge nodes around the periphery here. But beyond this, in light blue, this is the 6 field. This is all uniform 6-edge nodes here, all around here. Well, the reason for the distortion is that this is not a simple field. The embedment of this torus in the ground state, in the 6th field, changes it, distorts it. And that's easy to see. Along this edge here, there are 9 nodes. Along here, there are 4. Along here, there are 5. Along here, there are 7. Along here, there are 4. And along here, there are 5. I'm saying 5. 6. Okay. So this ground state, the 6th field, is highly distorted. It's not simple. Let me show you this in a diagram. So this diagram explains the difference between simple and complex 6 fields. This is a rather poor diagram of the structure of a 6 field that has 4 edges in all 6 directions. The structure that I was showing you before, the embedment of that red torus into the light blue 6 field, has these characteristics. There are 9, 4, 5, 7, 4, 6 edges around the 6 field periphery. So this is highly distorted. So what I did next was really ingenious. Very proud of myself. I took all of the red structure out. I cut it out. And that gave me just the blue structure. So then I had the red structure free, and I went back and I rebuilt exactly the same structure, so that I got back what I had to begin with. When I took the blue 6 field here with the distribution of lengths, number of edges that I told you about before, and I backfilled the structure, maintaining the 6 spines of the structure, I came to this state here, which is actually more distorted than before, because the toroidal object absorbs or induces part of the distortion. So freestanding by itself, the field is like this. So, you know, in physics they talk about every particle having a field. Well, you know, this is as close as I've come to exactly that. So these interactions here are some other set of events. Whether the single toroidal object is an adequate basis for distorting the 6th field in this fashion or not, I don't know. Certainly this structure here is interesting. I don't quite know what to make of this, but it is interesting. In thinking about how the 5-edge nodes on icosahedron might be moved together, I went back and looked at how signals flow in towards 5-edge nodes. So here's an example of single signal approaching a 5-edge node. You have the question, how does it exit the node? And the answer might be with a half probability in this direction or with a half probability in this direction. Similarly, when you have 3 signals approaching a 5-edge node, it's fairly clear that these 2 signals want to go here, but the other signal wants to return, as you see here. So then I had a crazy idea. I said to myself, well, supposing there's another edge here that we could add to the 5-edge node. These 5 edges are in the fabric and have the triangular neighborhood syntax. But supposing we add an extra edge, which I called an extra dimensional structural edge. And so this has interesting implications. Now we can reanalyze how signals flow or might flow at a 5-edge node. So consider again the example of one signal approaching. Before, we didn't know which way the signal should go. But now we could say, for example, that the signal goes out on the extra dimensional structure edge. And that seems like a perfectly rational solution to this single signal approaching. Here in the case where we have three signals approaching, before we didn't know what to do with this except to turn it around. Now we can say, oh no, it'll simply go out on the extra dimensional structure edge, and the other two signals will flow in the fabric as before. So in the same way that signals flow out of the fabric being the 5 edges coming into the 5-edge node here we can have a signal entering the 5-edge node via the EDS edge. And the question then is, where does that signal go? And one could say with 1/5 probability it goes in this direction, and then the same probability for the other directions at the 5-edge node. In the same way here, when we have two signals approaching and we happen to have a signal approaching from the EDS edge, now these signals can go as you would expect, but the EDS signal comes and goes in this direction. So then the question becomes, well, what do you do with these extra dimensional structure edges? So we can have here a very large fabric, which consists of a very large number of 6-edge nodes and 12 5-edge nodes. And then each of the 5-edge nodes will have an EDS edge coming inwards like this. And so what we can do is put a structure of 12 5-edge nodes in the center. So this is the EDS structure as opposed to EDS structure edge. So what we have now are two triangular neighborhood networks, the fabric, so-called, and the EDS, so-called. EDS, the extra dimensional structure. And this is pretty nice. I mean, the only problem is that this structure here is a triangular neighborhood network, and so is this, but then these edges are extra. They're in a different syntax. The same sort of diagram can be generated for the toroidal hole. Here we have the fabric of the toroidal hole, which consists of 6 and 7-edge nodes. To make a toroidal hole, you have some number of curvatures, 12 curvatures. Let's say there are 7-edge nodes. A 7-edge node has a curvature of +1. So if you had all 7-edge nodes constructing a toroidal hole, there would be 12 7-edge nodes. If you had 8-edge nodes, you'd have 6 of them, because the 8-edge node has a curvature, a positive curvature of +2, and so you'd have 6 8-edge nodes forming a toroidal hole. But in the same way we did with the icosahedron for a torus 0 structure, here for the toroidal hole we have, that is a EDS structure with 12 EDS edges coming in from the fabric to the EDS structure. I'll bring back the structure of the relationship between the fabric of the exterior triangular neighborhood network and the structure of the EDS, the extra dimensional structure. So what's interesting is that supposing you have some signals flowing along the fabric and they encounter the 5-edge node, and for whatever reason one of the signals then leaves the fabric and goes down through the EDS edge. The fabric can be arbitrarily large and has its own pace of events, but the EDS structure itself is very small. It has only, in this case, 12 5-edge nodes connecting it. So a signal entering from some random place where the 5-edge node happens to be on the fabric will come down into the EDS structure, where, because it's a triangular neighborhood network, signals will flow in a conventional fashion here, and then for some reason or other the signal may leave the EDS and go back along the EDS edge to this particular 5-edge node. So what we have here is, in effect, action at a distance, because an event that happens here can very shortly then become an event that happens here. And this is action at a distance. And I think this is logically all that one needs to be able to implement gravity as we think of it. Now, of course, we have to think in terms of much larger, much more complicated structures. We have to think in terms of the recursive nature of the triangular neighborhood system. But all of that considered, what we have now is the ability for an event here in a particular piece of the fabric at a given level to influence events far away. The only other way you have of influence of this events happening here influencing events happening here would be for a very slow transmission of signals or defects across the possibly great distance between this node and this node. And that is what gravity is. Having built the EDS structure for a torus, we can now apply that concept to something larger, for example, a galaxy. So a galaxy is characterized in many cases by a toroidal hole at its center. Now, whether the toroidal hole is causative or only merely a property of the galaxy is not clear, but the notion in the Triangular Neighborhood Networks of a bag and then a toroidal hole at the center is quite ordinary and simple. This bag could be filled with all sorts of other objects, stars, whatever, and dust. As we saw from the application of the extra-dimensional structure idea to the question of a galaxy, here too we could apply the extra-dimensional structure relationship between two triangular neighborhood networks in trying to understand how the Big Bang could proceed. That's a whole discussion in video 14, and you'll have to look at that video to see what it says. In the end, there are 15 videos that take altogether about 6 hours. I've listed the times for each video on the left. The first video is an introduction. The second one is on growing triangular neighborhood networks. The third is on scaling the ground state and pipes. Fourth is on grammar, curvature, and toroidal objects. The fifth is on recursion. Sixth is on signal flow. Seventh is defect propagation. 8 is the change of levels of toroidal holes between one level and another. 9 is the melting of an icosahedron. 10 is the idea of particles and antiparticles. 11 is interaction of different pipes. 12 is the structure of various fields. 13 is a discussion of gravity. 14 is a discussion of the Big Bang. And 15 is the summary.